Hi everyone and welcome to this new video in which I continue my web exploitation series. In this video in particular we will talk about the enumeration of HTTP parameters. So this means a couple of things. The idea is, let's say that you have an HTTP GET. So this is an HTTP GET request. So this GET request can be something like index.php maybe. Now the idea is, GET request can have parameters in the URL here. I can have, like, for example, parameter param1 equal value 1. Now the idea is, how do we discover if a given HTTP GET endpoint has a certain number of parameters? And let's say that we know that there is a specific parameter. How do we know the different values that go into this parameter? How can we understand how the web application behaves if we give certain values or maybe other values and stuff like that? This is for the GET. There's also the HTTP post, so we have the post data. Maybe we have a JSON body or we have just the form URL encoded data within the post. So in all those scenarios, we need a way to enumerate the possible parameters, to enumerate the values that go into those parameters, and so on and so forth. And so this is the idea for this video. I hope it is interesting. If it is, leave some feedback in the comments. Leave also some feedback if you didn't like something that I said. This is the 11th video for the series. After this, we will need 2 more, brute forcing and DNS zone transfer, and then we will be completed with the web exploitation series for OSCP. This is really cool. And now we can just start with the content of this video. So we go into the directory, and here there is the content. Here there is the Docker file. So as always, I have a Docker file. This Docker file defines the web application. Here I have essentially just a single PHP script in www.html-orders.php. We will not read the source code for that. We will analyze the application in a black box way, in a dynamic way. This is what happens when you do a black box penetration test. You don't know the source code. You can just interact with the application through HTTP messages. And by doing that, we will discover a bunch of things. So this is the idea. Now, how do we build this? The command is docker build. Then we can give it a name. The name is going to be enum parameters lab. And then we give a dot because the Docker file is in the current directory. So this is how you build it. I already built it, so it's gonna be pretty fast. If you didn't build it, you're just gonna have to download like the images from PHP and so on and so forth. After you build it, we can use the Docker Compose. So the Docker Compose is pretty simple. We just defined this enum parameters lab with the image that we just built. We give it the container name, and we say, look, I want you to bind the 1337 port of my host into the 80 port of the Docker. So internally the Docker is going to run a web server at port 80, but I will be able to access that web server through this endpoint, which is the localhost IP with the 1337 port, the elite port, my favorite port. So we can do Docker Compose up, and it's gonna make our Docker up and running. And so now here the application is up and running with the Docker. And in this other tab, I've prepared the burpsuite community edition and the Chromium instance that proxies to the burp. So this is a setup that I've already showcased multiple times throughout the series. So now we can go into this. Notice we get a forbidden. Why? Because there's only one resource here, and it is /orders.php. So once we go into the page, what do we see? We can check the HTML code. There's really nothing here. It just prints out need a user ID. I don't even close the body and the HTML tag, so this is not really like proper code, but hey, it says, look, I just need a user ID. Another thing that we can always do and that we should always do is check out the headers. So these are the headers that are sent by my browser, by the Chromium instance, and these are the headers that the web server replied me with. So this is the response headers. And notice it says, look, I'm powered by this version of PHP. Now, typically, this is considered an information disclosure because you don't want to tell your attacker the exact version of your software. But in this case, since it's a home lab, we are not exposing it to the internet, it's fine to leave out the version. Just remember that in case you want to expose a service, you might want to hide such information to external users, because the user of your application does not need to know these technical details. These are details that are good for maintaining the site, but they should only be viewed internally in like a different point of view. So this is the idea. Now, here it says need a user ID. So we can assume that the user ID is passed through a parameter. Here we have a get request. So maybe the idea is, oh look, we just need to add something like a parameter here, like I don't know, for example, test equal asked. We can sort of like do this. And we have a query like this. We can send it to the repeater, and we can put different like parameters like test asked 1, 2, and so on and so forth. So this is the idea. Now, when we have like this kind of situation, doing it manually is just impossible, right? Because you don't know what is the exact name for the parameter that is used by the server. Maybe you can make a guess, right? It's sort of like ID. Maybe because it's a user ID, right? Is it written like a D? Is it written like ID caps with caps lock? We don't know. So what's the idea? As usual, when we have an enumeration scenario, we want to go through a bunch of possibility in order to discover if in all those possibilities there are some which are useful to us. So in this case, we should make a list of possible parameter names and then just do a lot of requests where we just change the parameter name to check if the server replies differently. Because the main idea here behind parameter enumeration is that if we find the correct parameter, then we can expect that the web server will behave differently, that the web application and therefore the response sent by the web server will respond to us differently, with maybe a page with a different content length, with different content, with a different tag here. We don't know exactly, but the idea is if we find the correct parameter, we expect a change in behavior, while this behavior is the default behavior that it has when we have an incorrect parameter. Because for example, here we can add another parameter and nothing is gonna change. I'm still gonna get this content length and I'm still gonna get the same exact page. So not much here. So how do we do this? Well, the idea is to use a tool, and the tool I will be using is called Wfuzz, Wfuzz. Now this tool is really useful because essentially it allows you to fuzz for these sorts of parameters. It allows you to discover these sort of things. And so this is the idea. Now this is the Docker Compose Lab. We can just leave it up. It's really no big deal. Now down, how do we use Wfuzz? Well, the first thing is that we need a word list, right? So we need a list containing all the different parameters that we want to test. Now, as I said in the previous enumeration videos on files and directory and virtualhost, the management of word list is not a trivial task. I mean, you really need to build your word list based on real data, based on what developers typically use, based maybe on leak that have happened in the real world maybe years ago and stuff like that. So in this case, like a default good word list is the ones that are exposed by the seklist GitHub. And in particular for this case, I'm gonna use this one. I'm gonna use this one, which is it is in the seklist. It is in the seklist repository, and it is in discovery web content, and it's called burp parameter names. So in this list, we see a bunch of parameters, of like names that can go into parameters. There are a lot of them, of course. For example, CSRF token, cursor, CASD, customer ID, cat, CV module, CV number. So like there are a lot of things like that. So how do we get this? It's really simple. So I go here. I have already downloaded it, but let's say I didn't have it. So I'm gonna remove it. There's not here anymore. We can just use the following wget commands. And all the commands I will use today will be available in my GitHub. There will be a txt file containing all these commands. So if you want to repeat this sort of lab in your own environment, you can do that with no problems. You just need wget, and here is the URL where I downloaded the list. So I just press OK, and here I have my list. So I can open it. I can find a lot of, for example, if we search for ID, we see a lot of different IDs: gift, aid, id, im id, item id, network user ID, PHP SSID, parent ID, payer ID. Like we have a lot of occurrences of that. Now, I don't know exactly how many of these things there are. I think we can search, I think we can find the lines. Okay, yeah, we can find the lines like this. And it says there are 60,000 lines. 6,000 lines, not 60. 6,000 lines, 6,453. Let's see. Yes, this is also said by my Emacs here in the down. So there are around 6,000 parameters, almost 6,000 and a half. So there are a lot of parameters, right? So how do we actually use Wfuzz? Well, the idea is that we can either download it with Python with pip install Wfuzz. However, I had some problems with some libraries, with some Python modules, and this sadly happens, especially with Pythons, when maybe one of your dependency uses a package that has been deprecated, so it doesn't really work correctly. Thankfully, however, the author of the Wfuzz package, they also give out a Docker image. So the idea is that we're going to use Docker to run a container. In that container, we will have Wfuzz. So that's the idea. How do we do this? The new command essentially is this one. So let's try to analyze it, but first let's remove a bunch of stuff. So it is another docker run command, right? Because it's docker run. Then I do this, I do network equal host. Now, why do I need this flag? I need this flag because my laboratory currently resides on the localhost interface. So the Wfuzz within the container, if this is like the container of Wfuzz, this is the container where I have my vulnerable web application, and this is my host. So the idea is that this thing has to communicate with this thing. So they have to communicate because otherwise I cannot test that application with a Wfuzz instance running in a container. So the way to do it, the easiest way to do it is instead of making like a Docker network that you can also do that, but the easiest way that I found is just to say, look, network host, which means act as if this Wfuzz is running on my localhost network. So it has access to all my localhost, my network interfaces, like the network interfaces of my host. And so that's the idea. So with this, I can just say, look, go to 127.0.0.1, and then you will find this application because this is the same interface that my host uses to communicate with that. Then we do this, so we mount a directory. So to mount this directory, we get the current path. This pwd says, print me the current working directory, and sort of like expand it. So in the final bash command, this is gonna be the entire directory from the slash, from the root directory to this directory. Then you go into word list, and then you attach this to the internal directory of the container called /word list. And so the idea is that by doing this, I'm able to put the word list that I want within the container so that I can access it, because this is like a resource that I need to access. Then we say essentially where to take the image. So this is IT is where to take it. Then with IT, we make it interactive so that it gives us like a sort of interactive shell. Here we say we specify the image name. So this is like the full image that is present in the Docker repository online so that we can download it if we don't have it. And then we specify the command we want to execute on this Docker container. For example, we just say Wfuzz. If we do this, what's gonna happen is that it's gonna activate the container, it's gonna execute the Wfuzz command, and then it's gonna stop. So this is the result of the Wfuzz command executed. Now, how do we actually use it, right? We can say, for example, --help to get the common help with all the options and stuff. So a first usage would be like this. So we can sort of like do it like this. So let's say we have Wfuzz. The first thing is we specify the word list. So we do -w, and the -w is to go from the /word list root directory, because remember, this path is gonna be taken from within the container. So we cannot just say .dash, because .dash would start from our current, but it's actually /word list. Then we put the burp. So let's say, how was the burp word list called? Like this. So I'm gonna be /this like this, and then I start with a slash here. Perfect. Then I continue. How do I continue? Well, I put the URL where the application resides. So in this case, it's http 127.0.0.1.1337. It's the port. Then I say orders.php because this is actually the resource. And then this is the interesting part, right? So I want to fuzz for parameter names. So I do this question mark, then I do fuzz equal fuzz, and I put everything in quotes here. And this is it for our first wfuzz command. So let's just review it within this buffer, which is better. I'm gonna zoom in. So we say docker run, we set the network to dealing with the network. Then we specify, we mount this word list, then we say that it is interactive, then we specify the image, and then this is the actual wfuzz command. So if you were to install wfuzz locally on your machine, you would just have to execute this single command. You wouldn't have to do all this docker run stuff. I do this docker run because it is easier to build with dependencies and stuff. It is just like, it's much more easy to manage. So I do this wfuzz, then I put the word list, then I put the URL, and here I say, look, you're gonna read every parameter from this word list, and you're gonna replace it here whenever I write fuzz. So this fuzz keyword in capital letters means change me with all the different parameters that you take from the word list. Which means that for every element in this word list, we're gonna get a different query where these two values are different depending on the value that we picked from the word list. And we're gonna iterate through all the 66,000 possibilities. So if we run this command, what do we get? Let's run this command. We get a bunch of different results. So we get a bunch of different results. Now I stopped it with Ctrl+C. And what do we get for each of these results? So the idea is that for each of these results, we have the response code, the number of lines, the number of words, and the number of characters within that response. Notice that for every payload, and here the payload we use to trigger this behavior of the web application. So the idea is that when using wfuzz, we sort of like filter the behavior of the application depending on the status code, the number of lines, words, and charts of the content of the response. And this is the idea. This is already pretty powerful. We don't even need to go into the details on the content itself. This view is already pretty powerful, and we will see why. So here we have the payload. Now notice that for all those payloads, we get the same 526 character response. So we sort of like get the same behavior. Now, why is that? Well, remember that 526 is the default answer we get when we put a wrong parameter here. So the idea is that, look, these parameters are all wrong. Actually, we don't even want them to show in our output because we want to hide them because they are sort of like not working parameters. We did not really discover anything. Well, the idea is that we have control over what we can filter or not filter, because wfuzz, of course, does not know the specific logic of the application we are analyzing, and so it gives us various parameters to hide this sort of stuff. If we go back and we say -help, at the end here, notice this, we have hide the responses with specified code, lines, words, and charts. So we have these 4 different parameters, hc, hl, hw, hh. So these sort of like hide code, hide lines, hide words, hide charts. So that's it. Yeah. Now, what do we want to do? We want, for example, I mean, it doesn't really matter, but we can just use this. So we want to do after the word list, before the URL, we put hide charts. And so this is like a double, hide charts, and here we put the number that we want to hide, which is, if I remember well, 526, yes. So we go with this again. Notice what we get now. Now, all the previous lines are not shown anymore. They are filtered because they just reply with the default thing. But notice this, however. We have one line now that says, look, this line does not have 526 characters in the response, but rather it has 563. And the payload we use is actually user ID. So it's user written in a lowercase, then ID in capital, and then D in lowercase. This means that with this command, we are able to discover that the correct name for the user ID is actually user lowercase, then ID equals something, for example, test. And notice, now, the behavior of the application changes. Now it says order list of test, but then it says incorrect user ID. So it's sort of like we understood the name of the parameter, but we still don't know the proper value that it has to go there. but that's still a step forward, right? Before we didn't even know it was called user ID. And maybe in a different application it's called ID. In a different it's called user ID all in capital letters, so we don't know exactly, and the order does matter. And notice here that the capital of the fact that I is of a capital letter, it does matter, because with this, we get this incorrect user ID. If we just put it into a lowercase, we get the need a user ID. So it's sort of like, I mean, in this case, you can argue like, look, it says literally on the response that it's called like user ID with this specific syntax, so you could have just used that. That's right, but of course I wanted to show a more general approach, a methodology to discover these things, because you don't want to just find quick solution for your single web application. Rather, you want to build methodologies that work across different web applications. Methodologies and strategies that you can then adapt to your own workflows, to the specific application you're testing, or the bug bounty program you're doing. So now we discover one parameter. We can try to do this. So let's try now to discover if there are more than one single parameter. Because sometimes it happens that the application actually expects more than one parameter, right? So what can we do? We can put, like here we know now that there is a user ID, right? And we can put here test, whatever. Then we say end, and we put another parameter. At this time, we find this like this, same as before. But now we have hard-coded the user ID. So now the user ID is not gonna be replaced, and we will see if there are more parameters. So if we run this, notice that now we still get a lot of answers because we have to adjust our filter code. So it is no longer 526, it has to be 561 now. If we do this, do we get something? Let's just wait. I mean, I know, I wrote the code for this application, so I know. Notice this, we get two results. So we get user ID, and then we get debug. So this is really interesting actually. So we get a debug parameter that only appears, however, when we have selected the correct user ID. Because if we don't have the correct user ID, then we cannot access this debug. However, if we do have chosen the correct user ID, then we can add a different parameter called debug. So let's do that in our web application, right? So we say end debug equals debug. And the application replies us with nothing. Let's say, for example, debug equals a single hyphens. Once again, the application replies us with nothing. It's just an OK with nothing. If we say, for example, who am I? The application replies us with www-data. So what does this mean? It means that we simply have a remote code execution. Why? Because in the code, this debug parameter is used to execute like commands on the operating system. And so we have sort of like a backdoor, a custom backdoor that is hidden by a specific parameter that you can only access if you know the name of both of these parameters. Now, this example might seem like a far-stretched idea, like who would do that? However, some people actually do that. Like sometimes people put this sort of like debug backdoors that can, however, be abused by anyone because they do not handle the authentication process properly. So this is not authenticated. It does not ask me if I was the developer of this application. It does not ask me for any cryptographic proof or stuff like that. Once I discover the parameter, I'm inside. I can just get the host name. I can just get any information. I can leak the source code. So for example, if I can say cat var www html orders.php, what do we get? We get the source code of the application. So it's really, really simple. Before finishing the video, I just want to mention more scenarios. So once again, what did we do so far? We discovered the user ID parameter and we discovered the debug parameter, which led us to a remote code execution. So this sort of like parameter enumeration, parameter fuzzing, you could say, can be useful to discover stuff like that. Now, however, let's go back to just the user ID, right? So it says, look, I can get the order of the order list of someone, right? But in this case, the user ID is not correct. So the idea once again is what kind of value can I put in here, right? Well, in this case, what I do know from coding the application is that here it takes like an integer number, like for example 1 or something like that. Of course, I know this because I coded the application. In the real world, how should you approach this? The idea is that you try to use the application as a normal user and you just observe while using the application the kind of data that the application uses. So for example, if you have your own account with your own order list, you can observe, okay, what goes here? What goes in there? Is it a number? Is it like an identifier written like an hexadecimal string? So by observing the application, you get an idea of the type of data that that specific parameter is able to process, essentially. So in this case, I know it is a number. So the idea is that we have to find a specific number which allows us to get to see the list of orders. Now, how do we do that? Well, we can use Wfuzz or we can use intruder. So in this case, we can also use intruder from burpsuite. We can say send to intruder. And here we say, look, here I'm gonna put in this value here, I'm gonna put add this kind of thing. It says, look, I want to change the value of this, just of this. The attack type is essentially, the attack uses a single set of payloads. It places each payload into the first and places the same into all the position at once. I think sniper is good because we just have one payload that we want to test, essentially. So we do, for example, we do payloads. In the payload, we're gonna say like numbers. We're gonna go from 1, let's go to 1000, so that's 1000 requests, and we do a step of 1. It means that we start from 1, then we go to 2, then we go to 3, 4, so and so on and so forth. So this is the idea. Then the resource pool, we can use the default resource pool, and I mean, this is it essentially. And okay, so we can just do this. We can just start the attack. Contains a demo, but intruder is disabled, and attacks are time throttled. So as you can see here, it is extremely slow, and just to like finish this thing, it's not gonna happen anytime soon. So what we can do is we can actually generate this list of integer and use Wfuzz to perform the same thing, but in a much faster way. So in order to do the same with Wfuzz, of course, we need a word list, and this word list should contain, like I can call it numbers.txt. And this word list should contain all the different numbers that go from 1 to 1000, for example. In this case, it would be like this. So how do we do this? Do we do this manually? Of course not. We have to avoid doing things manually as much as possible. We can use bash. So the syntax for generating a range in bash is pretty simple. We can say for e in, then we can put the braces 0.1000, and then we can say semicolon do echo $I, and then we do done. If we do it like this, it's gonna print in a standard output all those numbers. So notice all those numbers in a standard output. And then by simply doing a redirect of the standard output into the file, numbers.txt, boom, we have our file, and this file now contains all the numbers of our interest. Perfect. Now once again, what do? Well, we can just use Wfuzz essentially. So we can just go here and use we can say Wfuzz, perfect. The word is gonna be like this, but now it's just gonna be numbers. So it's gonna be numbers. Let's not hide anything for now, and we're gonna put user ID equal fuzz. So now the fuzz, we're just gonna put it as a value of the user ID parameter. So if we run this, what do we get? We get a bunch of 260 essentially. So we want to hide also, hide 260. Let's see what we get. A non flag, because of course I did it too before. It should be like here. It should be after the word list. 560. Okay. So do we get? No, it's 559. 500. Let's see. 559. 558. So we get a bunch of different possibilities. Now notice this. While this so what's the idea here? Is that if you notice in the web application actually, so let's go to burp, let's go to the web application. So notice what happens here. We actually print the number itself. Now what does it mean in terms of content length? When we have one number, it's just gonna be 1 byte. When we have two numbers here, like 10, it's gonna be 2 bytes. When we have 3 numbers, it's gonna be 3. When we have 4, it's gonna be 4. So there's like a slight adjustment of numbers. Indeed, notice here it's like 228, 558, 561. While, so this is like small differences between this and this. While notice that for two specific cases, which are 123 and 256, we have a lot of difference. We have like, so for example, in this case, notice this, it's interesting, right? Because I was just looking at the numbers, and in this case, we should not filter with respect to the characters, but rather with respect to the lines. Because the lines, they only change, they don't change most of the time. So we can change hide lines, I can do 38, and now, notice what we get. We just get these two, which have different amount of lines. They have 42 lines each. So this is like very, very, very interesting command. Gonna save it because I did not have it, but essentially that's the idea. And now, so what's the idea? What happens when we put 1, 2, 3 here? 1, 2, 3? Well, notice that we have the order list for this particular account. We have a specific item with a specific price, with the payment, maybe this is like a credit card or something like that. This is 1, 2, 3, and then we have 2, 5, 6, which has different items with different payments. So that's the idea. Now, this sort of vulnerability is called an IDOR, and it is an authorization bypass. This is like when the application does not authorize properly the clients. Now, in this case, we don't even have authentication, but the idea is that this data should be private, and only the owner of this account should be authorized to view it, because only the owner of these orders should be view. They're like, okay, I paid with this card to get this, I paid with this card to get this, this is the price, these are the items. So like these are sensitive personal data, and the fact that we are able to access them just by understanding the ID of the user is called an IDOR. And this vulnerability is called an IDOR because it means essentially insecure, of course, direct object reference. So the idea is that since by understanding the ID, we can simply ask the web application to say, look, directly, give me the data for this user ID. And since there is no authorization check, which means that it is insecure, we have an insecure way of directly obtaining information regarding this specific account, which could be like, in general, it's called object, but it could be like data, it can be like personal information, you know, like a lot of stuff. Maybe we can change the password given the user ID. Maybe we can do different operation. We can do maybe a bank operation using the user ID. We don't know, but the idea is that anytime by simply using the identifier for the user, we get access to sensitive information, or we can perform a sensitive operation on the behalf of that specific user, then we have an IDOR, which is a problem with authorization. So this is like a really cool example, and to discover it, what did we do? First, we generated a word list made up of numbers. Why numbers? Because I developed this application and I knew it was made of numbers. If you did not develop the application, you have to check how the application behaves, what kind of data does it use as values for these parameters, and then you can create the appropriate payloads to test out. And then we use Wfuzz. In this case, we did not filter for the amount of character, but rather we filter for the amount of lines. And with the query was like user ID equal fuzz. Now to finish off the video, I want to mention two more things. Let's say that something does not work and you want to debug the requests that are made by Wfuzz, and specifically you want to send them to burp. So here I have burp. I can play around with this request, so I can remove all the requests that I made so far. I want to fill this proxy history tab with all the requests that Wfuzz makes. Now, how do I do this? Well, the idea is to use a parameter called p. So I can use p. Actually, I can still hide for the amount of lines. And then I can say p 127.0.0.1.88 and then HTTP like this. Now, if I do this, so before we actually send the command, we have to go to the filter history and we have to remove this show only in scope items. So we have to remove this. We just say apply, so no filters. We press here and notice that our history here is filled with requests, where each request is made by Wfuzz. Notice this user agent, right? It's made by Wfuzz. And as you can see, we also understand much better the way it works. It simply makes many requests by changing this user ID field. It just changes this and it just makes many requests. So that's the general idea. Now, if you go back, for example, to the commands we used to discover, like let's say, to the commands we used before to discover the debug parameter, for example, Yeah, this is good. And then here we can put -p 127.0.0.1.88 HTTP, and we remove everything that is going on here, and we just send it again. Once again, we're filled with requests, but notice now the difference is that the request is made with a different HTTP parameter. So what changes is the HTTP parameter after the user ID. So that's the general idea of parameter enumeration. Of course, it's not like super easy. It can be really difficult to do because many web applications have a lot of different parameters and a lot of different things to search for. Now, one last more thing before I actually finish is, okay, in this case, we just put a get. Let's say that we actually want to make a post, and let's say that we want to make a post with a certain body. So what do? Well, if we go to the Wfuzz help menu, I always suggest to do it, and we can say like method, specify an HTTP method. So to specify the HTTP method, we can use a -x, that's x post. So let's say if this works. Notice at the end, go at the end. Now we make all post, right? So now we make all post, that's good. So we can just clear this history because it's a lot. And now let's say that we want to put some like data in the body of the post. We can do this with the -d because look at this. I think it's like post data. Let's search for post data, post data, this -d. Use post data id equal catalog 1, for example. So we can say -d, we can put this data, and then we can just put it as before. So this I'm gonna save this command just to showcase in the final commands.txt that I will put for everyone. I can just send this, and now notice what do I get? I get a lot of requests, right? But now in the post data, I have id equal localcode, id equal link. So the values that are read by the word list are put within the value of the id parameter in the data, in the body of the request, not in the get URL parameter, but in the post www form URL encoded data. So that's the idea. Now, of course, this was just the beginning for this topic. I'm just gonna introduce you the basic idea, but there are a lot of things you can do. But I hope it was interesting. So in the next few videos, we are almost done with this series. We just need brute forcing of credentials and DNS zone transfer. And then we are officially done with the web exploitation series. I'm really happy for that. After this, we can talk about Linux. And that's it. To the next video.